Welcome to Study Loop.
Hi there. In this question, we have a gas stoichiometry problem. And it's considered a gas stoichiometry problem because all of our reactants and all of our products, and especially the reactant and product that we are most interested in, are gases. So since it's a stoichiometry problem, the first thing we need is a balanced chemical equation. So we are reacting fluorine gas, and fluorine is a diatomic, so I have to write it as F2. It's reacting with water vapor. So that would be H2O. Vapor means a gas. We are producing hydrogen fluoride, which is HF gas, and oxygen gas. All right, well, to balance this, I'm going to actually start out with the oxygen. There's one oxygen on the left and two on the right. So I need a 2 in front of H2O to balance the oxygen. That gives me 2 times 2, or 4 hydrogen. So I need a 4 in front of hydrogen, or in front of HF. That gives me 4 fluorine, so I need a 2 in front of F2. All right, so this balanced chemical equation gives us a couple of things. One thing it always gives us is the mole ratio. So in other words, 2 moles of fluorine react with 2 moles of the water to produce 4 moles of the HF and 1 mole of the O2. So these numbers are coming from the coefficients, 2 to 2 to 4 to 1. When there's no coefficient written, it's understood that it's a 1. Okay, but since these are gases, since this is a gas stoichiometry problem, and we are not informed of any change in temperature or pressure as the equation is taking place, this is also the volume ratio. So 2 volumes of F2 react with 2 volumes of the H2O vapor to give us 4 volumes of the HF gas and 1 volume of the oxygen. Volume could be milliliter, it could be liter, it could be any term that measures volume. Well, specifically, we are reacting, or we used up 6.6 milliliters of the fluorine, and we want to know how much oxygen would be produced. All right, so since it leaves it up to us, it just says what volume, I'm going to leave it in milliliters. So in other words, I'm converting from milliliters to milliliters. So I can just use the volume ratio. Let's go ahead and set this up and see what that would look like. I'm starting with 6.6 milliliters of the F2. And our coefficients, our volume ratio, shows us that for every 2 volumes, in this case, the volume is milliliters, for every 2 milliliters of fluorine gas, we're going to produce 1 volume, or 1 milliliter, of the oxygen gas. All right, milliliters will cancel. 6.6 times 1 divided by 2 gives us 3.3 milliliters of the oxygen. That's how much oxygen we're going to produce. So that would be our final answer. Thanks so much for watching, and I hope this was helpful.